Scientific notation is a way to write really small or really large numbers, or any normal numbers if you wanted to, but it wouldn't make sense to use scientific notation if a number doesn't take up much space in standard notation. So the definitions are, we have, it's a number. It has to be between 1 and 10, that's the first part, multiplied by 10 to a power. Okay, this whole thing is scientific notation. Often the number can be in the millions or billions, but you can write it as a number between 1 and 10 multiplied by 10 to a power. Well, 10 to a power is just like 10 to a power, 10 to the 20th power, multiplied. And we'll pick a number between 1 and 10, like 3. So that's scientific notation. It's a number between 1 and 10 multiplied by 10 to a power. Now this number that we're multiplying by, we didn't specify that it has to be a whole number. So it could be 3.1289 times 10 to the 216th power if we wanted to do that. But we have to have, this number has to be, in order to be strictly in scientific notation, there has to be a single digit in the ones place. And then you can have the decimal in as many digits as you want to after that. If you have a positive power 10, that's going to be representing a number that's greater than 1. So it could be like if we have, let's just say 8. Sorry about that. 8 times 10 to the 5th power. This was going to be, I'm just using a small example to make a point here. This would be 8 times 10 times 10 times 10 times 10 times 10. You would never do this, but you see, would it be 8 with this many zeros? 1, 2, 3, 4, 5. So it would be 1, 2, 3, 4, 5. 800,000. So 8 times 10 to the 5th, which is in scientific notation, is equal to 800,000. And the 800,000 is in standard notation. Now, if this was 8 times 10 to the 500th, it would be 8. And then can you figure out how many zeros it would have after it? Here's a hint. How many zeros? Right, 500. And we can't get them all in. What about 8.23 times 10 to the 7th? I'll make 7th because I can actually get that on here. Okay, to make sense of this, your number in standard notation is going to start with 8, 2, 3, followed by zeros, but not 7 zeros. Why not? Because of this. That's going to move 7 places. 1, 2, 1, 2, 3, 4, 5, 6, 7. 82,300,000. So 8.23 times 10 to the 7th, 8.23 times 10 to the 7th, scientific notation, is the same as 82,300,000 in standard notation. When you have a negative power of 10, you're writing a number that's between 0 and 1. It's a small number. It's approaching 0. It could be approaching 0. So a negative power of 10 would look like something like 10 to the negative 3rd power. So if we have 7 times 10 to the negative 3rd power, we could write this as 7 times 1 over 10 to the 3rd power, right? So we can switch this negative exponent to the positive exponent, which would be 7 times 1 over, and now 3 zeros after this, or 7 thousandths. Or better off written as, we have to bring it up here, 7 tenths, hundredths, thousandths. So how did that happen? Well, we had the 7. And if we'd put a decimal, it would be right there. right? This tells us how many places the decimal is going to move from here. It's going to go to the left. So if I started and I move the decimal 3 places to the left, so we go 1, I need to put a 0 here, 2, 3. It starts here and goes over 1, 2, 3. So the decimal would go here, and we have to put the number 0 in to hold that place. So let's take a look at another one. Let's go 6.29 times 10 to the negative 5th power. So I'm going to have to move this decimal 5 places to the left. By the way, if this were a positive 5, the decimal would be 5 places to the right. So that's the general rule. Locate the decimal. If it's a whole number, like 7, the decimal would be right after. Before we start calculating with scientific notation, do a review of product of powers and quotient of powers. In the first example, we have 10 to the 6th times 10 to the 7th. Remember that you add exponents, so it's going to be 10 to the 6th plus 7, or 10 to the 13th power. When you divide 10 to the 4th divided by 10 to the 3rd, it's a subtraction problem, 4 minus 3. This would be 10 to the 4 minus 3, or 10 to the 1st power. And I don't have to put that 1 there. I could just write 10. So that's just sort of a lead-in to some of the problems that we're going to do. We have 4 times 10. I'm just going to use these examples. 4 times 10 to the 6th multiplied by 5 times 10 to the 7th. And this notation means take this stuff here, multiply by everything here. I can use the commutative property of multiplication to rewrite this as 4. I'm just changing the order. Commutative property says I can change the order. 4 times 5 times 10 to the 6th times 10 to the 7th. 4 times 5 is 20. And 10 to the 6th times 10 to the 7th is 10 to the 13th. Now, if you thought you were done, you're not. You're not wrong. I mean, this would not be an incorrect answer. 20 times 10 to the 13th. That's equivalent to the correct answer. However, that's not scientific notation because 20 is not between 1 and 10. 20 is 2 times 10 to the 1st power. So I can make this 2 times 10 to the 1st power times 10 to the 13th power. Now it's still not scientific notation, but it's getting easier to see what it should be. Can you get it? 2 times 10 to what power? Hope you're thinking 1 and 13 make 14. 2 times 10 to the 14th power. Okay, we're going to move to another slide to show a division problem. First of all, I admit to making these problems really easy. But there's nothing wrong with starting with easy problems when you're first learning how to do something, right? So we have 12 times 10 to the 6th divided by 4 times 10 to the 2nd. We can break that into 12 divided by 4 times 10 to the 6th divided by 10 to the 2nd. That should be pretty easy to see. It's going to be 12 divided by 4 is 3, and 10 to the 6th divided by 10 to the 2nd is 10 to the 4th. And here's a problem that's a little more challenging. 10 times 10 to the negative 3rd power divided by 5 times 10 to the negative 7th power. So first thing we're going to do is split this up into this part and this part. So we're going to break this apart, break that apart. So it's 10 divided by 5, which is easy, times 10 to the negative 3rd divided by 10 to the negative 7th, which is a little more challenging. Okay, so the 10 divided by 5, hope we're on the same page, that's 2. And 10 to the negative 3rd divided by 10 to the negative 7th would be 10 to the negative 3 minus negative 7. Double parentheses here. So now we're going to go keep, change, change. Plus, positive. 2 stays the same. What's negative 3 plus 7? That's it.